EPC contractor. The capacity, about 80% of the total project cost that has been fixed. And we have given the financial capability of EPC contractors. All these three tenders have been floated, pre-bid meeting completed. We are going to upload the corrigendum also in a week's time. And by November, all these these will be the timeline which has been agreed. I hope so that tenders will come. So thank you a lot. I will just say that Coal India is giving the opportunity to various EPC contractors and licensors to come up with their proposals. 3 projects are going to come up. About 40,000 crore rupees is the investment committed, and we hope so that we will take up this mission of Government of India. Thank you.
Thank you very much, Dr. Peeyush Kumar, for sharing the latest developments in the coal gasification. We see some actual actions being taken, and we hope that the projects come online and time-wise and really demonstrate that these are very much doable thing and would definitely provoke other industry to also come up here. Thank you very much for your presentation on this. Now I'll invite Dr. Prakash Chavan, who is the Chief Scientist and Head of the Gasification and Catalysis Research Group at CIMFR. They've done really leading work in terms of not only designing the gasifiers, but also on the efficiencies of the gasifiers. So please request you to make your presentation. Yeah.
Namaskar, dignitaries on the dais and colleagues from coal sector. I will try to restrict my presentation with some important slides only. When we talk about gasification, really we need to concentrate on 3 things. Systematic understanding of the feedstock. This is one of the most important aspects, I will say, because all the decisions related to selection of technology as well as operation, because gasification cannot have a standard operating procedure. We need to always link operating procedure with the characteristics of the feedstock. So systematic understanding of the feedstock is always, it is necessary whenever, whether we will go for installation of new technology or utilization of feedstocks in any installed facility. So it will be continuous process throughout the exploitation of gasification for any end application. When we talk in Indian context, already we have covered certain aspects related to gasification potential mapping of resources from various subsidiaries of Coal India, mainly MCL, CCL and ECL. Still we need to do this exercise for remaining subsidiaries also before going for any implementation of gasification. And next, because there are 3 important technologies for gasification. So on the basis of understanding of feedstock, once we select suitable one, then how to indigenize that those technologies. Suppose if we go for any commercially proven technology, so there should be systematic approach so that it will be successful implementation. So decisions related to pre-processing of the feedstock to make it suitable for particular selected technology, then to handle the feedstock systematically in the gasifier, how to overcome operational issues, how to predict how it will behave inside the gasifier, as well as to make the syngas, generated syngas suitable for any targeted application, what type of syngas microcleaning conditioning will be required, to what extent it will be required. So to make all these strategies, we need to have a systematic plan that which we can cover under the indigenization of particular proven technology as per our available resource. Then comes the development of indigenous technology. Already we have executed certain activities under this particular aspect. We have achieved certain milestones, and even we have developed systematic protocol for selection of the suitable technology, technically suitable, I will say, according to the feedstock characterization or understanding of the feedstock. Now coming to the indigenization part, this will be the important aspect before going for implementation, because lot of pre-processing will be required. Technically, one can go for any technology out of the three technologies for gasification, whether it is high ash, low ash, any type of can be handled technically. But feasibility is an important aspect to get the success. So what type of pre-processing will be required? So there, that exercise we have to do. Then to handle it successfully inside the gasifier and at downstream. These three important areas we need to concentrate. If we go consider one case, say coal feedstock having around 45% ash content, in that case, washing will be required to bring down the ash content up to 20%. Technically, various gasifier manufacturers are claiming that that particular technology will handle high ash containing coal also. But we need to think, if we go for high ash content gasification in any technology, feasibility will be important concern, because we will be feeding huge amount of minerals inside the gasifier. So it will decrease total efficiency, it will decrease the net gain out of what we are feeding it to the gasifier. So definitely washing, once we go for high temperature gasifiers like entry and flow gasifier, definitely we need to go for washing also. So expenses, capex, opex related to that, yield, all these factors we need to consider. Then certain important parameters, mainly because Indian coal ash is having certain typical characteristics. So we need to take into consideration, and accordingly we need to go for suitable gasifier, because it will definitely require high temperature entry and flow gasifiers only, not low temperature like GE or ConocoPhillips, where slurry feed is utilized. Then for moving bed gasifier, which is being utilized by GSPL, again washing will be required. They have tested feedstock having more than 30% ash content, but issues are there. So again washing will be required, capex, opex for that. Then byproduct generation in the form of tar and liquid products, as well as this particular technology have limitations related to particle size. So out of 1 ton, really how much we can feed to the gasifier, we need to consider, because again JSPL have certain concerns related to this aspect. So considering all these aspects for both these technologies, systematic technical as well as economic feasibility analysis is very much essential, though particular technology can handle any feedstock, because ultimately economics will be the crucial parameter. So considering summarized all these parameters, washing, blending, power requirement at each and every module, for oxygen generation, for washery, as well as other several aspects, means net coal required for per unit syngas generation, we need to find out, and other capex, opex and overheads also. So now coming to the indigenous technology development, we have achieved milestone up to pilot scale development at various institutions, organizations. And next step, already Peeyush sir has elaborated for demo scale or mini commercial scale plant, they are moving forward. Here, just I am sharing achievement at our institute. We have developed 1.5 TPD oxyblone fluidized bed gasification pilot plant. We have tested various high ash containing feedstocks and generated syngas quality is quite comparable with the even proven gasifiers like Lurgi. It can be utilized for any end application, targeted applications. To move forward, we have opinion that it should be taken forward in the form of consortium because as such it is a really complex phenomena. Lot of challenges are there at each and every stage. So involvement of R&D institutions, engineering houses definitely required for higher scale and user side industries also. So that we can successfully establish operational philosophy, what we have established in pilot scale at higher capacity also. And even we can address other aspects related to for commercial exploitation. Now coming to the, I will skip this slide. Now coming to the usage part, underground coal gasification, again certain typical requirements are there. Site selection really very important aspect. Then development of injection well, production well. To some extent we have know-how or we can take this type of support from other agencies because we are working in the area of CBM, petroleum. So to some extent we have inputs or experience in this particular aspect. Then important aspect is linking, again certain know-how is available, but considering furnace, UCG furnace development, cavity development and systematic maintaining the cavity throughout the process, really it is one of the biggest challenge apart from other environment related aspects. Then operation control to get the desired quality and consistent quality syngas to convert it to the desired product. Then environmental aspects, how to avoid the contamination of surrounding, whether it is water bodies or environment. So these are typically important aspects for UCG. I will skip this. Basically, three types on the basis of depth UCG we can exploit. One is shallow up to 500 meters and then medium to depth